Mesh analysis. Mesh is closed loop which does not contain any other loop within it. In above example, there are two mesh available. 1. A, B, E, F, A, 2. B, C, D, E, B. Procedure 1. Check whether circuit is planar or not. 2. Assign direction of tracing current in mesh. 3. Write Kirchhoff's voltage equation for each mesh and solve them to get answer. Remember that number of equation is equal to number of mesh. While writing KVL equation for any mesh when we come across particular element, assigning polarity to that element is important thing to understand the sign of potential difference across it. Voltage source and current sources are having their polarity. For resistor, we apply logic that the terminal where current enters is positive, and from where current leaves is negative. In given figure, current enters at A terminal, so it is positive, and leaves from terminal B, so it is negative. Base for this is current always flows from higher potential to lower potential. When there is resistor is common between two mesh, then there are two different currents related to that resistor. In such case, important thing to write equation is remember that for which mesh you are writing equation, and whether both currents are in same direction or in opposite direction. In above example, I1 is current for mesh 1 and I2 is current for mesh 2, both currents are in opposite direction. So while writing KVL equation for mesh 1, voltage drop across R1 is R1 I1 minus I2. Sign of voltage depends on tracing direction. Similarly, while writing KVL equation, mesh 2 voltage drop across R1 is R1 I2 minus I1.
In this second example, I1 is current for mesh 1 and I2 is current for mesh 2. Both currents are in same direction. So while writing KVL equation for mesh 1, voltage drop across R1 is R1 into bracket I1 plus I2. Sign of voltage depends on tracing direction. Similarly, while writing KVL equation, mesh 2 voltage drop across R1 is R1 into bracket I2 plus I1. Solved example. Apply KVL to mesh 1. 10 minus 5 I1 minus 2 into I1 plus I2 equal to 0. 7 I1 plus 2 I2 equal to 10. Equation 1. Apply KVL to mesh 2. 5 minus 10 I2 minus 2 into I2 plus I1 equal to 0. 2 I1 plus 12 I2 equal to 50. Equation 2. By solving equation 1 and 2 simultaneously, current I1 equal to 0.25 ampere, current I2 equal to 4.125 ampere. Note that direction of current and tracing shown by blue line.